Algebra 1, Common Core, Unit 6, Section 3. Linear systems algebraically with the elimination method. So the previous video was the substitution method, 6.2. And, as we have two linear equations, we know we could graph them and graphically see where they cross. And the substitution method was a way to kind of plug one into the other. The whole concept between this is linear equations have two variables. They have x's and they have y's. And if I have two equations with two variables, I have to figure out a way to combine them to be one equation with one variable so that I can then solve for the variable. So the substitution method is a great way to do that. But there is another option that we call the elimination method. Some people refer to it as the addition method. Because basically what we're going to do is we're going to add the equations together. And while we're adding them together, we're hoping that one of the variables cancels out. So a big part of this is the concept of additive inverses. Because if I want things to cancel out through addition, they need to be additive inverse pairs. And basically, that's the same number with an opposite sign. Like 5 and negative 5 are additive inverses. Negative 7 and positive 7 are additive inverses. Let me just write this down. So negative 7 plus 7 equals 0. 5 plus negative 5 equals 0. Same number, opposite sign. And they add together, they cancel each other out. That's what an additive inverse is. So sometimes that's set up for you. Sometimes it's not. And you need to change your equations to do that. So sometimes you need to use multiplication to change an equation so that it has the numbers together. So let me show you kind of what I'm talking about. Now the first step, as noted here, so this is the problem that we're going to do here. And this is set up nice for the substitution method because y is alone. So you could do the substitution method here. Sometimes you're told you have to do one method over another, maybe on a chapter test. I don't think a Regents exam would ever, tell you have to use elimination or substitution. But there are times where one is easier than the other. That's why we make a point to teach you both methods. So looking at this right away, substitution probably would be the way that I would go. But we want to practice the elimination method. So the first thing you'd want to do, the first step, is aligning up the terms. So what that means is I need everything to be on top of each other like terms. So my first column is my x terms, my second column my y terms, then I have an equal sign, and then the constants, the numbers without variables, are on the right side of the equal sign lined up together. So everything is in columns, columns together. And so you had to move some things around. So for this first equal, I had to subtract 3x. Or it looks like we actually ended up kind of reversing things around here, that I minused y over to this side, and I minused 1 to the other side, and then moved things around. Here I minused 4x and added 4. But this is what the problem typically looks like. Sometimes you'll have to rearrange things, but most of the time when we're doing the addition method, things are kind of set up for you like this. But if it's not, line them up. Now, what you want to look at is if I add these together right now, like if I just add these things together, add these columns, combine like terms in these columns, I get 3x and negative 4x. That would be negative 1x. Negative y is like negative 1y, positive 2y, that's plus 1y equals negative 1 and 4 combines to be 3. Notice that when I add them together, I still have an x and I still have a y. So that's not going to work. I got to figure out a way that so I add them together, something cancels out. And so the thing here, it's okay if you wrote that down, but the thing is, looking at this, you need that concept of additive inverses. That's really the key to this whole thing. Notice that 3 and negative 4 are not additive inverses. Negative 1 and 2 are not additive inverses. And so I need to change one of my equations through multiplication to get it like that. So you kind of look at your x numbers. Can I turn a 3 into a 4 or a 4 into 3 with multiplication? Well, not easily. Can I change a negative 1 into a 2 or a negative 2? Yes. See, 1 is a good number to have because you could change the number 1 into any other number with multiplication. Think about it. If you have the number 1 and I want it to be an 8, I multiply it by 8. If I have the number 1 and I want it to be a 4, I multiply it by 4. Same thing with negative 1. I mean, you got to remember that a negative times a negative is positive, and when you multiply opposite signs, you get negative. But this is so that's a useful coefficient to have when you're trying to do this method. Again, sometimes things are set up for you, but so what we're going to do in this example here, if you follow through, is we're going to take this top equation and we're going to multiply it by 2. Because when we multiply this top equation by 2, we distribute, that becomes 6x, negative 2y, negative 2, and that's what our new equation becomes. And so then when I line them up again, now I have that very important additive inverse column, where I have a positive 2 and a negative 2 on top of each other. So that's really the trick. I'm trying to get a column where I have the same number on top of each other with opposite signs, so that when I add the two equations together, they cancel out, or they add to 0. And then the rest of the problem doesn't cancel out, but because the y's cancel out, now I just have an x, and then I could solve for x, divide 2 on both sides, get x equals 1. And then the second part is just like the substitution method. Once I have one of the variables, I just plug it in to find the other, and the answer here is 1/4. So let me do a couple examples for you, start to finish. All right, so we're solving this with the elimination method. Now this is lined up for you. First thing you want to check is it lined up? Are the x's on top of each other, the y's on top of each other, the equal signs and the constants on top of each other? Yes. So first step, line it up, done. Next, do we have an additive inverse? And in this case, we do. Notice that we have the 2, negative 2. That's your additive inverse. AI, I'm going to call it. And so we have the additive inverse, so we're ready just to add these things together. And combining like terms, so negative 3, positive 5, that combines to be a positive 2x. These cancel out, equals 16, and negative 12 is 4. So the positive 2 and negative 2 adds to 0. We don't bother to write the plus 0. And so we have 2x equals 4, divide 2 on both sides, x equals 2. Then I could do a little substitution. You could pick either equation. I'll take the top one. So negative 3x plus 2y equals negative 12. Well, now I know x is 2, so I'm going to replace this x with 2. Negative 3 times 2 plus 2y equals negative 12. That's negative 6 plus 2y equals negative 12. Add 6. Add 6. You know, when I add or subtract things to get them to the other side, again, I'm doing that additive inverse concept. And so we have 2y equals negative 6 when I'll add those together. Divide 2, y equals negative 3. And remember, we like to write these answers as coordinates of x comma y. So 2 comma negative 3 is our final answer here. So that's it. When you have them lined up and have additive inverses to start with, it's really quite, a pretty simple process. Just simply add the equations together, solve for the variable, plug it in, and get the other one. So one of the things that a lot of people like this over substitution, even though it probably sounds more complicated at first than substitution does, but once you see it, most people tend to prefer this method because it can be a little bit quicker. Like we got x equals 2 real fast just by adding the two things together, where to do substitution here, it would be tough, because you don't have a variable alone and you'd have to move things around and divide and might get fractions. So the elimination method sometimes is a much easier method. Let's do another example here. All right, so first, is it lined up? X is on top of each other, Y is on top of each other, equal signs on top of each other, constants on top of each other. Yes, all lined up. Do we have the additive inverses? Do I have a 3 over negative 3 or 1 over? No. Do I have a 3 over negative 5, those additive inverses? No. I don't look for additive inverses there because I'm not looking for that to cancel. I want a variable to cancel, so I only have one variable left. So this is like what we were doing over here, where we are not given an additive inverse to start, and we had to use multiplication to get it. So again, you kind of have to look at this and say, how could I get an additive inverse? Remember the number in front of x here is a 1. And we talked about this earlier, or I talked about it, and hopefully you're listening, that 1 is a great coefficient for this because I can turn that 1 into a 3. I could get 3 over negative 3 here for my additive inverse. Is it possible to get an additive inverse here? Yes. There are some complicated cases where you might have to change both of them, where if I multiply this by 5 and this by 3, then I'll end up having 15 over 15. But we're not going to do that. We're going to take the easiest method we can. And so if you don't have the additive inverse to start, look for the coefficient of 1. If the coefficient of 1 is not there, again, look at the things on top of each other. Like, are they multiples of each other? You know, could I turn one into the other with multiplication? Worst case, you might have to change them both. But this one's not too bad. So what we could do here is I can multiply this top equation by 3. And what that will do is it'll end up giving us a positive 3 over negative 3 additive inverse. But I'm not just going to be multiplying that by 3. When you multiply, remember, you got to distribute everything, both sides of the equal sign. So this is going to become 3 times 1x is 3x. 3 times 3y is 9y. 3 times 1 is 3. Don't forget, you're multiplying that 3, not just by both of these, but the other side of the equal sign too. Everything in the row gets multiplied by that 3 when you distribute. And that is over the bottom equation, which is unchanged. So negative 3x minus 5y equals 5. But now we have the additive inverse we were looking for, because it's the same number, opposite sign on top of each other. Now we can add them together. They cancel out because they add to 0. Positive 9y minus 5y is a positive 4y. Positive 3, positive 5 adds to positive 8. Divide 4, y equals 2. See how easy, once you get that additive inverse, how easy it is to solve for a variable. Now again, just pick any equation. I'm going to take the top one, x plus 3y equals 1. And I suggest you rewrite the whole thing and then rewrite it with substitution. X plus 3 times 2 equals 1, right? You got y equals 2, so you can replace y with 2. X plus 6 equals 1. Move the 6 over. Why am I writing minus 5? I got a minus 6 because the answer is going to be minus 5. I'm thinking in my head. X equals negative 5. Oops, crossed it out there. Let me try that again. Much better. And so that's it. And then the answer is a combination of these, negative 5 and 2. Now we could check these, just like we did a substitution method. You could plug these in, like once you have these answers, I could plug this in for x and y and see if it works, into both equations, see if it works. But I'm pretty confident in our answers here, so I think we're good. So that is it for 6-3 linear systems algebraically using the elimination method, sometimes referred to as the addition method. After this, probably do some modeling word problems with this type of stuff, and then we go into inequality graphs and inequality systems. See ya.